Recording in progress.
I'm gonna start chapter 4, and that's basically start of trigonometry. Radian and degrees measures. So that's two popular way of measuring angles, radian or degrees. Angles. Well, everybody knows angles. You know, if you have two lines intersect and they have angle between them, they call this one vertex. And here is always we have start and stop. So initial side, terminal side. When we have a coordinate system, X and Y, we make, let's say if I have a line like that from 0, 0. So this is an angle. We always start from X counterclockwise, okay? Always go that way, counterclockwise. That's a positive. Okay, that's a positive, always from X. So this is, let's call it theta. This is an angle. I can have another angle. If I have a line here. So what's the angle? I have to start from X, right? Counterclockwise. So always my initial is the X-axis, and this is the terminals. It can be that long. Okay. Sometime if we call this is phi, sometime we may call this one here negative gamma, whatever the angle. If I go backward, then we call it negative angle. This is an example, positive. This is positive angle. That's negative angle. Okay, we have something also called coterminals. What does that mean, coterminal? There's two angles, they have the same terminal. Like if I have an angle alpha here, If I have another angle, negative beta, so both of these angles, they stop at this location. So we call them coterminal. Or if I have this angle, alpha, then if I go start from here and keep going, and stop at the terminal, this is the angle beta. Actually, as we're going to find out, I can go around and around forever. If we stop always at the same location, it's called coterminal angle. The smallest one is really the basis. We're going to learn has a name. I think they call it coterminal angle. Radian measure. If I have a circle, and that is a 0, 0 here, X and Y. If I, in the circle, the radius is R. Now, if I make an angle theta, so I move to a new location, still this distance called R. Let me do it again. So if I move along the curve, by a distant S, and I'm making angle here theta, and this is the radius R. There is a relations between all of those three. S equal R theta. Theta must be a radian. Must be in radian. Now, if S equal R, theta equal 1 radian. So that's the definition of a radian. That we're taking an arc, that arc has the same length as R. And what happened, that will make the angle equal 1 radian. Now, if I try to make another, if I make another S thing, one, two, three, four, five. I didn't do it right. Should be 6. Well, let's look at the drawing in the book. You can see here, if I made a curve 1R, so this is R, there's another R, another R, another R, another R. I can go around 1, 2, 3, 4, 5, 6 radian around the circle, but I have some left over. So the entire circle, it is 6.28 radian. And also we call it 2 pi. How much is the pi? 3.14 radian. Pi is 314 over radian. Pi is, what is the definition of the pi come from? What is the area of the circle? Anybody remember? What's the area of circle? It's equal pi r square. How long is the out parameter? The entire parameter. How long is it? You can tell from here. Remember we said S equal R theta. What is S? So if this is the length of the curve. If I keep going all the way around until I go back to the same location. If I start from here and go back to here, there's a full circle. How much the angle should be? Full circle. Two pi. Theta equal 2 pi. Right? Then the length, the entire length, S total equal 2 pi r. Who invented the pi? And where's it come from? That's very interesting, right? How come it's pi 3.14 and and how do they calculate it? I think the Greek who invented the 2,000, 3,000 years ago invented the pi. How do they invent the pi? I'll tell you how they did. Because they're doing a lot with constructions and need to do some calculation and they use a lot of circles in their design. What they found out, the following interesting phenomenon. If I have a small circle and radius r, and the entire length outside, let's call it S1. If I have another circle much bigger, have a different radius, and the outside is S2. They find out no matter how big or small the circle, S, the length over the radius equal constant. It does never change. They measure it, they made a circle on the ground and they find a way to measure the parameters and they measure the radius and they've been doing some calculations. They found out that's never changed. And they said, well, that's constant, we can name it pi. And it came up to be 3.14. Well, excuse me, yeah, 3.14. Or actually they did the diameter initially, it was the same thing. So they found out that it's a number. Actually should be, I'm wrong here. still, let's see in here. Yeah, S over R, it is a constant, but it is 2 pi, not 1 pi. Which is 6 2 pi. Or if I said S divided by the diameter, that would be 1 pi. It's kind of interesting. It's just remark, they noticed that by observation. Then since that time, they've been using the pi. And they call it 1 pi is 1 radian. 1 radian. So the number 314 radian. So the pi equals 3.14 radian. And I'll show you how they find out, how they name 1 radian, 2 radian, 3 radian. When R equal S, that's 1 radian. So half a revolution, if okay, one revolution equal 2 pi. So that means if I go all the way around, start and end from the start back to the same start, it's called 1 revolution. Half revolution, you divide by 2 is 1 pi. Quarter of revolution, 2 pi over 4 become pi over 2. 1/6 of revolution, 2 pi over 6 pi over 3. Here we go. So this is 1 revolution, 1 rev. This is half rev. This is 1/4 of revolution, which is a 90 degree. Okay, pi over 2 equal 90 degree. Then pi over 3, then pi over 4, and pi over 6. And what they did, they said, if I have X and Y, this is 4 areas, right? That's 4 areas. We call this one, the first one, quadrant 1. If we go to the left like that, counterclockwise, that's counter quadrant 2. Then keep going down, quadrant 3. Keep going this way, that's quadrant 4. So we're gonna learn, sometime we're gonna refer. I give you an angle. What quadrant? You need to figure it out. What quadrant that angle is. Well, how would you know? If the angle between 0 and pi over 2, that's quadrant 1. If it's between pi over 2 and pi, quadrant 2, then pi and 3 pi over 2, that's quadrant 3, 3 pi over 2 to 2 pi, that quadrant 4. That's the way you figure out what the quadrant. Well, they kind of like, we can use instead of X and Y, we can say that location here, theta equals 0. If I go up, theta pi over 2. Go down to horizontal, theta equal pi. Vertical, theta 3 pi over 2. So then I can figure out where I am. You go back to the original, theta equal 2 pi. So this location, theta 0 or theta 2 pi. Here was I saying, like, if I have an angle pi over 6, what quadrant should be in? If this is 0 and this is pi over 2, and this is pi. Well, pi over 6 is somewhere in here. This is pi over 6, right? Should be between 0. So that's quadrant 1. So this angle is in quadrant 1. Well, if I start again, as I told you a minute ago, go around and stop here. That's just a new angle. So that's coterminal. But what is the value of the new angle? Well, if I went around 1 revolution, that means I've been adding 2 pi. So if I have, so that angle here is pi over 6 plus 2 pi, because I made additional 1 revolution. I can make it 2 revolutions, 3 revolutions. I can go forever around and around and around. That's the way it works in trigonometry. So that angle can be infinite value. And if we keep going to pi over 6, that's called coterminal edge. And this angle, the coterminal angle. So when we, how do I say I can go around forever? I can say pi over 6 plus 2n pi. The meaning is n could be 1, 2, 3, 4. So n number of revolution. N is number of revolution. Okay? Because the 2 pi is 1 revolution. If I multiply it by n, it's going to give me any number of revolution. If I ask you like this question here, what is the coterminal angle for this angle? 13 pi over 6. Well, this 13 pi over 6 definitely more than 2 pi. So what we do, we take 13 pi over 6 minus 2 pi. I'm going to subtract 1 revolutions so I can get the coterminal angle, which is the smallest one. How do you subtract them? 13 pi over 6 minus 12 pi over 6. So I just make the common denominators. So I converted the 2 to be 12 over 6, which is okay. Then 13 minus 12 equal 1 over 6. So this is the coterminal angle for this angle. Now, what is the coterminal angle for 37 pi over 3? How do I find it? To find the coterminal angle, what you do, you say minus 2 pi, then continue minus 2 pi, until you reach to the smallest angle. Okay, but this is a long process because I don't know how many times I'm going to subtract 2 pi. It's easier. How about try to figure out number of revolution first? How much is 37 divided by 3 equal to? 12.38? 33. Okay, 333, like that. So basically, you can see here, I have a 12,333 over pi. That's my angle. If I divide by 2, that will give me number of revolutions. So this has become 6.1666 of 2 pi, correct? So now I know I have 6 revolutions. Really, this is the fraction, that's my coterminal angle. If I take point, whatever left over, 666, multiply by 2 pi, that will give me the angle I'm looking for. Can you do that? Tell me how much is that? .3333, I think, over pi. 0.33333 over pi. That's basically pi over 3. 1/3. That is my coterminal angle for that one. Okay. That's the process. If you have a huge angle, that's what you do. You figure out, you divide by, actually, you divide by 3, then divide by 2. That gives you a number of revolutions. You take the fraction part, multiply it by 2 pi, will give you the coterminal angle. Now here they have, now what happens if they give me negative? What is the coterminal for this angle? Negative 2 pi over 3. Well, what they did to find the coterminal, they added 2 pi to it. And they got 4 pi over 3. What happens if I have negative 37 over 3 pi? That's much bigger than that one. That's as easy. Adding 2 pi, I'm done. I cannot just keep adding 2 pi, 2 pi, 2 pi. To find the coterminal for this one, we do the same process. We said we can divide 37 by 2 times 3. It's going to give us 6.1666. Let's keep it negative. What you're going to do here, we're going to round it up to the next higher level. See, last time I used a fraction. This time I'm going to say 7, this is the next higher number, minus 6.1666. And that, if I multiply it by 2 pi, will give me the coterminal angle. How much is that? Can somebody tell me how much? Multiply 2 by this number, 7 minus 6.1666. How much is that? $10? Okay, 10.665, you said? Okay, 668. Oh, that's okay. Over pi, right? That can be good. So basically what happened in here, the angle was it's ended here. So basically was the pi over 3 over here. So what we calculated all of this angle. Okay, well, still what I'm saying. So one, okay. Did you calculate it, Maria? Okay, 1.66, okay. So basically, this is 1 2/3 over pi. And that's 3, 1 plus, this is 5 pi over 3. Okay, so the angle, the coterminal, basically 5 pi over 3. So this angle here, from here all the way to here is 5 pi over 3. The coterminal angle, because this is negative. So that's the way the method, that's the way we do it. If they give me the angle in negative, I go the other part. I have to go to the higher one, say 7 minus, and get the number and multiply. If it's positive, I just take the fraction part to find the coterminal angle. Then another definition, complementary angle and supplementary angles. Complementary angles, alpha plus beta equal pi over 2. That's complementary. Supplementary, alpha plus beta equal 180. Oh no, 1 pi. If we're talking in pi right now, it's the pi, or 180 degree here, or 90 degree. So adding those two angles, pi over 2 or 90 degree, supplementary, you add them up, it's pi or 180 degree. Degree measures, we already been talking. Degree is basically one revolution equals 360 degrees. That's one revolution. So basically 2 pi equals 360 degrees. 1 pi equal 180 degrees. And pi over 2 equal 90 degrees. How do we convert? Let's learn how to convert between radian and degree. I'm going to teach you a method a little bit different from the book. Let's say convert 2 radian to degree. What you do, you always let's say pi is 180 degree. Okay, which is a radian. Now what is given? What is given is the radian. So I put the radian under the radian. That's what's given. What I'm converting to? Degree. So that means I don't know it. So I'm gonna call it X or unknown, whatever, X. So that's what I'm looking for it. So the way you do it, you multiply, divide by, multiply, divide by. X equal 2 times 180 divided by pi. How much is that? So the answer should be in degree. Degree. You have a pi in your calculator. All what you have to do is 360 divided by the pi, you get the answer. 1.114? Okay, degree, that's the answer. That's in degree. Now, if I ask you convert 290 degree to radian, how do I do it? I start the same way, pi 180, same way. What is given to me is degree. I put the degree under the degree. What is looking for is X. So the same thing, I'll leave the X alone. X equal multiply divided by. So X equal pi multiplied by 290 divided by 180. See, both, I can use the same method for converting left or right. $5.06. So if you just do this method, you don't need to know what the book is doing, which is most books do the other method. That's the way I learned it because that's the easiest way. The other way, what they said, if you're converting from, let's say here, I'm converting 2 radian to degree. From, it should be in the bottom. So I have to write 180 over pi. Then that's called converting factor, then multiply it by 2, which is correct. Always, when I'm converting, when I convert from degree to radian, I multiply by pi over 180. That's converting factor. But I don't need to remember which one on the top, which one on the bottom with this method. Okay. Let's practice this. See, do I have a practice one? Let me go check. Where did I convert those to? Convert 330 to radian and convert 5.7 radian to degree. I need to add something. Find coterminal angle for 27 pi over 6. And for negative $25 pi over 3. So we have 4 problems. Convert 330 to radian, convert 5.7 radian to degree. Also find the coterminal angle for 27 pi over 6 and negative 25 pi over 3. The same thing we just did a minute ago. Tell you what, let's pause for a minute. Let me finish this section so we can do all the practice. Remember, we said that for a circle, if I have an angle theta, and this is radius r, and the curve here is s. S is equal r theta. Theta a radian must be radian. Otherwise, will not work. Okay. We have an example here. They said r is equal 4, theta equal 240. Find s, question mark. Well, theta 240, what did we say about theta, Maria? Should be what? What unit theta should be in? Radian, right? So I have to convert 240 to radian before I find, before I say S or R theta. So if I, again, the method we said pi 180, what's given is 240. We need to find theta and radian. So theta equals the multiplication, multiply, divide. So theta equal 240 pi over 180. That give me the answer, a radian. Well, they said is 4 pi over 3 radian. That's the theta now. Now, what is the length? S. R, how much is R? 4. So we say 4 multiplied by theta, which is, what is it? Multiplied by 4 pi over 3. So the answer is 16 pi over 3. That's the length. That should be the same unit. If we're using, they said 4, what the unit? They didn't say what unit, but doesn't matter. So if R equal 4 feet, then S also feet. If it meter, so the angle will not change anything. Should be okay. Angle is always radian. But whatever, if R in feet, the answer in feet. If R in inches, the answer is in inches. If it's in meters, the answer in meters. So it really doesn't matter for that scenario. But you have to remember, always convert to radian. I say they said inches here. So basically the last answer is 16.76 inches. That is how long is that curve for the given angle. Linear and angular speed. Well, we'll talk about that later, the angular speed. Let's talk about the area of a sector. Area of a sector is given by this formula. Also, theta should be what? In radian. So area of a sector, half r squared theta. So that's what we're talking about. The one is highlighted with purple. Is half r squared theta. So whatever, if theta is given in degree, we convert to radian. If r, we know r, we can find the area of a sector. Let's see if they have example. Oops. So let's go back to this problem. What's the area of this sector? R is 4. How much the angle was in radian? Let's go back down and find out. So that's the angle of radian. So area, sector, equal half 4 square multiplied by theta 4 pi over 3. Just do the calculation, you get the area of the sector. It's a half r square theta. V, now when you drive your car, what is the unit of the speed? When you see a sign in the road, tell you speed limit something, what does it say? Well, the number, let's say it's 30, but don't they have something next to it? They may say 30 mph. What does mean mph? Mile per hour. So the speed is how many distance per hour, right? That's the speed. So speed V equal the distance divided by time. So whatever, if I traveled for half an hour with 30 miles per hour, what is the distance? Then you multiply time by speed. So the velocity is distance per unit time. Also, we're going to define something called omega. Have you heard of omega? This is Greek letters, okay? It's like a W, but with a nice curve. Omega is the speed of the angle, theta over time. That means how fast the angle is changing. How many radian per second. Okay, it's like your clock, how fast it's going. This is called angular speed. So this is linear speed because that's for straight line. Linear speed. This is angular speed. What is the relation between V and omega? We can eliminate the T between those two. T equal S over V from here. Also T equal theta over omega from here, correct? Just let me know, guys. Just look at it and tell me if this is correct. We just exchange position between the T and W and T and V. Set Z equal, what you're gonna get here? You get S over V equals theta over omega. Do cross product. V theta equal SW. We said S equal what? R theta, right? So if we said V theta equal R theta omega, I just replace S from here. Theta cancel out. V is equal R omega. That's very important formula. That's the way angular velocity and linear connected. Linear velocities equal R omega. There is example in the book. I don't have it in here. Shoot. But let me look at the example. Did you have your book, Maria? I need to give that example. We have this, the wind turbine. You know, the one they make electricity. This is a post. It's like a fan. It have wings. And this rotate like a fan. Let's say this is rotating that way. The length of each fin, 116 feet. This rotate 15 revolution per minute. Find angular speed omega. Find linear speed v. Why my battery is low? Oh, connected it. Okay. Well, this is how much they said number of revolution. We have 15 revolution, right? But what the angle? One revolution, how much? How many radian, one revolution? Tara, how many pi's or how many radian? 2 pi, right? So if I said then omega basically is 15 times 2 pi, give us 30 pi radian per minute. Now we got, this is basically the angular velocity, radian per minute. That one was revolution. How much is V? V is equal omega R. And that's equal 30 pi multiplied by 116 feet. If you multiply these, then we get the answer is feet per minute. Well, really, we are looking for the speed of the tip. That is the V. That's the speed of the tip. Because the center does not have no speed. That's the reason we multiply by 116 feet. Okay. It's always just a matter of user calculator. It's really not that hard, you know, pretty simple. All right, that section is over. Let's go back to the practice. Now we can solve everything you see in here. Because also I give you an example, 50 feet diameter carousel rotates 6 revolutions per minute. Find angular speed, radian per minute, and linear speed, feet per minute. You know, there is another example we cannot do. Let's hold on that one. I'm gonna delete it.